I'm trying to say that whatever consciousness is, it's not a computation.
Yes.
Or it's not a physical process which can be described by computation.
But it nevertheless could be. So one of the interesting models that you've proposed is the orchestrated objective reduction,
Yes,
which
well,
is
you see, that's going from there, you see. So I say I have no idea. So I wrote this book. Through my scientific career, I thought, when I'm retired, I'll have enough time to write a sort of a popularish book, which I will explain my ideas and puzzles, what I like, beautiful things about physics and mathematics, and this puzzle about computability and consciousness and so on. And in the process of writing this book, well, I thought I'd do it when I was retired. I didn't actually. I didn't wait that long because there was a radio discussion between Edward Fridman and Marvin Minsky. And they were talking about what computers could do. And they were entering a big room. They imagined entering this big room. At the other end of the room, two computers were talking to each other. And as you walk up to the computers, they will have communicated to each other more ideas, concepts, things than the entire human race had ever done.
Yes.
So I thought, well, I know where you're coming from, but I just don't believe you. There's something missing. It's not that. So I thought, well, I should write my book. And so I did. It was at roughly the same time Stephen Hawking was writing his Brief History of Time. And
in the 80s at some point. The book you're talking about is The Emperor's New Mind.
Emperor's New Mind, that's right.
And both are incredible books, The Brief History of Time and Emperor's New Mind.
Yes, it was quite interesting because he told me he'd got Carl Sagan, I think, to write a foreword.
It's a good get.
To the book, you see. So I thought, gosh, what am I going to do? I'm not going to get anywhere unless I get somebody. So I thought, I know Martin Gardner, so I wonder if he'd do it. So he did, and he did a very nice foreword.
So that's an incredible book, and some of this is the same people you mentioned, Ed Franken, which I guess of Expert Systems fame, and Minsky, of course, people know in the AI world, but they represent the artificial intelligence
Absolutely,
world.
that's right.
That do hope and dream that AI's intelligence is.
That's right. Well, you see, it was my thinking. Well, I see where they're coming from, and from that perspective, yeah, you're right. But that's not my perspective, so I thought I had to say it. And as I was writing my book, you see, I thought, well, I don't really know anything about neurophysiology. What am I doing writing this book? So I started reading up about neurophysiology. And I read up and I think, I'm trying to find out how it is that nerve signals could possibly preserve quantum coherence. And all I read is that the electrical signals which go along the nerves create effects through the brain. There's no chance you can isolate it. So I thought, this is hopeless. So I come to the end of the book and I more or less give up. I just think of something which I didn't believe in, as maybe this is a way around it, but no. And then you say, I thought, well, maybe this book will at least stimulate young people to do science or something. And I got all these letters from old retired people instead. These are the only people who had time to read my book.
So, I mean,
except for Stuart Hameroff.
Except for Stuart Hameroff.
Stuart Hameroff wrote to me and he said, I think you're missing something. You don't know about microtubules, do you? He didn't put it quite like that, but that was more or less it. And he said, this is what you really need to consider. So I thought, my God, yes, that's a much more promising structure.
So, I mean, fundamentally, you were searching for the source of non-computable source of consciousness within the human brain, in the biology. And so, what are, if I may ask, what are microtubules?
Well, you see, I was ignorant in what I'd read. I never came across them in the books I looked at. Perhaps I only read rather superficially, which is true. But I didn't know about microtubules. Stuart, I think one of the things that impressed him about them was when you see pictures of mitosis, that's a cell dividing, and you see all the chromosomes, and the chromosomes all get lined up, and then they get pulled apart. And so that as the cell divides, half the chromosomes go, they divide into the two parts, and they go two different ways. And what is it that's pulling them apart? Well, those are these little things called microtubules. And so he started to get interested in them. And he formed the view, he was his day job or night job or whatever you call it is to put people to sleep, except he doesn't like calling to sleep because it's different. General anesthetics in a reversible way. So you want to make sure that they don't experience the pain that would otherwise be something that they feel. And consciousness is turned off for a while, and it can be turned back on again. So it's crucial that you can turn it off and turn it on. And what do you do when you're doing that? What do general anesthetic gases do? And see, he formed the view that it's the microtubules that they affect. And the details of why he formed that view is not altogether clear to me, but there's an interesting story he keeps talking about. But I've found this very exciting because I thought these structures, these little tubes, which inhabit pretty well all cells, it's not just neurons. Apart from red blood cells, they inhabit pretty well all the other cells in the body. But they're not all the same kind. You get different kinds of microtubules. And the ones that excited me the most, this may still not be totally clear, but the ones that excited me most were the only ones that I knew about at the time, because they're very, very symmetrical structures. And I had reason to believe that these very symmetrical structures would be much better at preserving a quantum state, quantum coherence, preserving the thing without... You just need to preserve certain degrees of freedom without them leaking into the environment. Once they leak into the environment, you're lost. So you've got to preserve these quantum states at a level which the state reduction process comes in, and that's where I think the non-computability comes in. And it's the measurement process in quantum mechanics, what's going on.
So something about the measurement process and what's going on, something about the structure of the microtubules.
Yes.
Your intuition says, maybe there's something here. Maybe this kind of structure allows for the mystery of the
There was a much better
mechanics.
chance, yes. It just struck me that partly it was the symmetry, because there is a feature of symmetry. You can preserve quantum coherence much better with symmetrical structures. There's a good reason for that. And that impressed me a lot. I didn't know the difference between the A lattice and B lattice at that time, which could be important. Now that could be, that's an issue which isn't talked about much.
But that's in some sense details. We've got to take a step back just to say, in case people are not familiar. So this was called the orchestrated objective reduction idea, or OR, which is a biological philosophy of mind that postulates that consciousness originates at the quantum level inside neurons. So that has to do with your search for where is it coming from. So that's counter to the notion that consciousness might arise from the computation performed by the synapses.
Yes, so, I think the key point, sometimes people say it's because it's quantum mechanical. It's not just that. See, it's more outrageous than that. You see, this is one reason I think we're so far off from it, because we don't even know the physics right. You see, it's not just quantum mechanics. People say, quantum systems and biological structures. No, well, you're starting to see that some basic biological systems does depend on quantum. I mean, look, in the first place, all of chemistry is quantum mechanics. Right. People got used to that, so they don't count that. So he said, let's not count quantum chemistry. We sort of got the hang of that, I think. But you have quantum effects, which are not just chemical, in photosynthesis. And this is one of the striking things in the last several years, that photosynthesis seems to be a basically quantum process, which is not simply chemical. It's using quantum mechanics in a very basic way. So you could start saying, with photosynthesis is based on quantum mechanics, why not behavior of neurons and things like that? Maybe there's something which is a bit like photosynthesis in that respect. But what I'm saying is even more outrageous than that, because those things are talking about conventional quantum mechanics. Now, my argument says that conventional quantum mechanics, if you're just following the Schrödinger equation, that's still computable. So you've got to go beyond that. So you've got to go to where quantum mechanics goes wrong in a certain sense. You have to be a little bit careful about that, because the way people do quantum mechanics is a sort of mixture of two different processes. One of them is the Schrödinger equation, which is an equation Schrödinger wrote down, and it tells you how the state of a system evolves. And it evolves according to this equation, completely deterministic, but it evolves into ridiculous situations. And this was what Schrödinger was very much pointing out with his cat. He said, you follow my equation, that's Schrödinger's equation, and you could say that you have a cat which is dead and alive at the same time. That would be the evolution of the Schrödinger equation, would lead to a state which is the cat being dead and alive at the same time. And he's more or less saying this is an absurdity. People nowadays say, oh, well, Schrödinger said you can have a cat which is dead and alive. It's not that, you see. He was saying this is an absurdity. There's something missing. And that the reduction of the state or the collapse of the wave function or whatever it is something which has to be understood. It's not following the Schrödinger equation. It's not the way we conventionally do quantum mechanics. There's something more than that. And it's easy to quote authority here because Einstein, at least three of the greatest physicists of 20th century who were very fundamental in developing quantum mechanics, Einstein, one of them, Schrödinger, another, Dirac, another. You have to look carefully at Dirac's writing because he didn't tend to say this out loud very much because he was very cautious about what he said. You find the right place and you see he says quantum mechanics is a provisional theory. We need something which explains the collapse of the wave function. We need to go beyond the theory we have now. I happen to be one of the kinds of people, there's a whole group of people, they're all considered to be a bit mavericks, who believe that quantum mechanics needs to be modified. There's a small minority of those people, which are already a minority, who think that the way in which it's modified has to be with gravity. And there is an even smaller minority of those people who think it's the particular way that I think it is, you see. So
those are the quantum gravity folks. But what's...
You see, quantum gravity is already not this. Because when you say quantum gravity, what you really mean is quantum mechanics applied to gravitational theory. So you say, let's take this wonderful formalism of quantum mechanics and make gravity fit into it. So that is what quantum gravity is meant to be. Now I'm saying you've got to be more even-handed, that gravity affects the structure of quantum mechanics too. It's not just you quantize gravity. You've got to gravitize quantum mechanics. And it's a two-way thing.
But then when do you even get started? So that you're saying that we have to figure out a totally new ideas in there.
Exactly. No, you're stuck. You don't have a theory. That's the trouble. So this is a big problem. If people say, okay, well, what's the theory? I don't know.
So we may be in the very early days, sort of.
It is in the very early days. But I'm just making this point.
Yes.
You see, Stuart Hameroff tends to be, Penrose says that it's got to be a reduction of the state and so on, so let's use it. The trouble is Penrose doesn't say that. Penrose says, well, I think that. But
Yeah, right.
we have no experiments as yet which show it's that.
Yes.
There are experiments which are being thought through and which I'm hoping will be performed. There is an experiment which is being developed by Dirk Bouwmeester, who I've known for a long time, who shares his time between Leiden in the Netherlands and Santa Barbara in the US. And he's been working on an experiment which could perhaps demonstrate that quantum mechanics, as we now understand it, if you don't bring in the gravitational effects, has to be modified.
And then there's also experiments that are underway that kind of look at the microtubule side of things to see if there's, in the biology, you could see something like that. Could you briefly mention it? Because that's a really sort of one of the only experimental attempts in the very early days of even thinking about consciousness.
I think there's a very serious area here, which is what Stuart Hameroff is doing, and I think it's very important. One of the few places that you can really get a bit of a handle on what consciousness is what turns it off. And when you're thinking about general anesthetics, it's very specific. These things turn consciousness off. What the hell do they do? Right. Well, Stewart and a number of people who work with him and others happen to believe that the general anesthetics directly affect microtubules. And there is some evidence for this. I don't know how strong it is and how watertight the case is, but I think there is some evidence pointing in that kind of direction. It's not just an ordinary chemical process. There's something quite different about it. And one of the main candidates is that these anesthetic gases do affect directly microtubules. And how strong that evidence is, I wouldn't be in a position to say. But I think there is fairly impressive evidence.
And the point is the experiments are being undertaken, which is...
I mean, that is experimental. You see, so it's a very clear direction where you can think of experiments which could indicate whether or not it's really microtubules which the anesthetic gases directly affect.
That's really exciting. One of the sad things is, as far as from my outside perspective, is not many people are working on this. So there's a very... Like with Stewart, even it feels like there's very few people are carrying the flag forward on this.
I think it's not many in the sense it's a minority, but it's not zero anymore. You see, when Stewart and I were originally talking about this, we were just us and a few of our friends. There weren't many people taking it, but it's grown into one of the main viewpoints. There might be about 4 or 5 or 6 different views which people hold, and it's one of them. So it's considered as one of the possible lines of thinking, yes.
You describe physics theories as falling into one of 3 categories: the superb, the useful, or the tentative. I like those words. It's a beautiful categorization. Do you think we will ever have a superb theory of intelligence and of consciousness?
We might. We're a long way from it. I don't think we're even whether we're in the tentative scale. I mean, it's...
you don't think we've even entered the realm of tentative?
Probably no. I think.
Yeah, that's right.
No, well, you see, it's so controversial. We don't have a clear view which is accepted by a majority. I mean, you see, people. Most views are computational in one form or another. They think it's but it's not very clear, because even the IIT people who think of them as computational, but I've heard them say no, consciousness is supposed to be not computational. I say, well, if it's not computational, what the hell is it? What's going on? What physical processes are going on which are that?
What does it mean for something to be computational then? So
well, there has to be a process which is... You see, it's very curious the way the history has developed in quantum mechanics, because very early on people thought there was something to do with consciousness, but it was almost the other way around. You see, you have to say the Schrödinger equation says all these different alternatives happen all at once, and then when is it that only one of them happens? Well, one of the views, which was quite commonly held by a few distinguished quantum physicists, that's when a conscious being looks at the system or becomes aware of it, and at that point it becomes one or the other. That's a role where consciousness is somehow actively reducing the state. My view is almost the exact opposite of that. It's the state reduces itself in some way, some non-computational way, which we don't understand, we don't have a proper theory of, and that is the building block of what consciousness is. So consciousness is the other way around. It depends on that choice which nature makes all the time, when the state becomes one or the other rather than the superposition of one and the other. And when that happens, there is what we're saying now, an element of proto-consciousness takes place. Proto-consciousness is, roughly speaking, the building block out of which actual consciousness is constructed. So you have these proto-conscious elements, which are when the state decides to do one thing or the other. And that's the thing which, when organized together, that's the OR part in OR. But the ORC part, that's the OR part, at least one can see where one's driving at a theory. You can say it's the quantum choice of going this way or that way. But the ORC part, which is the orchestration of this, is much more mysterious. And how does the brain somehow orchestrate all these individual OR processes into a genuine conscious experience?
And it might be something that's beautifully simple, but we're completely in the dark about.
Yeah, I think at the moment that's the thing. We happily put the word "orc" down there to say orchestrated, but that's even more unclear what that really means.
Just like the word material, orchestrated.
Yes.
Who knows?
Yes.
And we've been dancing a little bit between the word intelligence or understanding and consciousness. Do you kind of see those as sitting in the same space of mystery as we've
Yes, well, you see, I tend to say you have understanding and intelligence and awareness. And somehow understanding is in the middle of it, you see. I like to say, could you say of an entity that is actually intelligent if it doesn't have the quality of understanding? Like, so I'm using terms I don't even know how to define. Right. But who cares? I'm just relating them.
They're somewhat poetic. So if I somehow understand them.
Yes. That's right. We don't, exactly.
But they're not mathematical in nature.
Yes. You see, as a mathematician, I don't know how to define any of them. But at least I can point to the connections. So the idea is intelligence is something which I believe needs understanding. Otherwise, you wouldn't say it's really intelligence. And understanding needs awareness. Otherwise, you wouldn't really say it's understanding. Do you say of an entity that understands something, unless it's really aware of it in our normal usage? So there's a three sort of awareness, understanding, and intelligence. And I just tend to concentrate on understanding because that's where I can say something. Yeah. And that's the Gödel theorem, things like that. But what does it mean to perceive the color blue or something? I mean, I'm the foggiest. That's a much more difficult question. I mean, is it the same if I see a color blue and you see it? Or if you're somebody with this condition, what is it called?
Or where you assign like a sound to a color.
Yeah, that's right. You get colors and sounds mixed up, and that sort of thing. I mean, an interesting subject. I mean, yeah.
But from the physics perspective, from the fundamentals perspective, we don't.
I think we're way off having much understanding what's going on there.